data-driven seminar series that hosted by the College of Ag. And today we have a very interesting presentation that coming up. But before I get to that, I just quickly want to remind there are 3 more presentations that are coming up. One will be from a visitor from the Nature Conservancy. So it's in a Geo group. So please check your calendar and make sure you come. I think Nancy could correct me. We will provide lunch
next week. Yeah.
Okay, so if you're hungry, come over. And then we have on November 7th to have another seminar. Yeah, it is yet to be determined, but hopefully we can get the titles and all that in place. And then the last one is on December the 5th. So today we have one of our own superstar here, Dr. Jinha Jung's group. Jinha is in the College of Engineering, School of Civil Engineering, and his work has been spanned through a very wide field on LiDAR application to general remote sensing, and he has some background even in soundscape. If you don't know what that is, ask him about it. But also he has been working in something in quite an interesting way of how to gather data, analyze data, visualize data, disperse the data in a very fluent and efficient and seamless way. So I'm not going to steal his thunder in this until he has a very interesting way of thinking how this is going to work through. And so this and I'll tell you this, I know his work for a while. And this morning during another meeting, I just learned, wow, we can't do that now. Okay, so that's the world stuff. And hopefully you'll learn something very interesting and later actually adopt the platform that his group is building. So without further ado, yeah.
Thank you very much, Songlin. Thank you for this great opportunity. Today I'm going to talk about a project that we've been working on. And at the beginning, we tried to come up with a name for this project. And essentially, like Songlin mentioned, I'm from School of Civil and Construction Engineering Geomatics area. And we used to be known as a surveyor. We are very good at measuring things at the very, very high standard. And using the drone technologies becoming more and more available everywhere. We used to do a lot of sense modeling for airborne system, satellite. You guys just take images from the space. How do you know these pixels coming from which location? That's what we do. Okay. So we've been working on this sensor modeling. We call also the geospatial data science in general. And we are very good at generating those kind of data sets. But we are engineers. We are not the scientists and actually working on this actual science. So I always see some needs where we have some data set being generated, but how can you link this data to actual science to do some innovation, and etc. So using the data to science and the naming coming from that idea, we have now a way of collecting in a big data set. How can we link this in big data set to the science to solve some of the problems that you might be interested in? And before I start, I'd like to acknowledge my the co-presenter or co-author of this presentation, and Minyoung Jung is a person working in my group, sitting over there, and Ben Hancock. And I'm going to be the one who is going to show all this magic today, but I'm not the one who is doing the work. He's the he's the one who is doing all this encoding in the background in order to I'm not sure how many of you attended that the digital forestry retreat that was about a month ago, and it was in a great event. And so, do you remember what's the name of the keynote speaker? Simon from England, and he used this in a phrase saying "seeing unseen." So when I first heard that term, I didn't know what it is, but some of you who already seen this in his presentation, I just borrowed this video from his presentation. Hopefully, I can just.
It's like
So this is the moment when you saw something for the first time you've never seen. So I want to ask you a question. When was the last time you had this kind of sensation before? Surprised by something that you have never seen before. Do you remember anything?
total solar eclipse this spring.
Oh, okay. Yeah. I'm going to tell you that this is something, of course, you need to be in a special location, but you truly enjoy, this moment when you can see something that you have never seen before. This is joyful, right? And what I want to do here is that, before I go into my presentation, I want everybody pull up your smartphone, scan this QR code, and see what you can see. And I hope, this gives you same face, expression that you saw from the video. And to give you an idea, this is, drone data set collected in Ecuador. The location called in the TBS, Tipitini Biodiversity Station. This is such a remote area. It took us 3 days to get there and 4 days to get out. And when we actually arrived there, the closest place where there's another human is 9 hours away. So this is such a remote area. And you can just look at this map. You can just zoom in, out. It looks like it's just tiny images, but as you zoom in, you're going to start to see very, very high resolution images that are being calculated. Right? So everybody can see this, right? And the trick behind here is that you guys are looking at images that is in the size of 170 gigabytes right now. So imagine that, hey, you collected something. I went through this, joyful moment where, wow, this is great. Now I can see it. I'm the one who actually can see something that I've never seen before. Even me personally, physically there, I can see those in the trees, but only from the edges. But I cannot go every corner of those the rainforest area. But now you guys have a capabilities to zoom into whatever area that you're interested in. You can see very, very detailed information, right? And this is another one. I'm not going to go through. You can just do, look at the 3D point cloud data set, the same thing as well. And this is, I mean, if you want to scan it, this doesn't work on a smartphone because you don't have enough GPU. You need to copy this URL, copy this URL back to your laptop, then you're going to see beautiful 3D point cloud collected by LiDAR as well. Okay. And I know there are some of you who already listen to my presentation a multiple times, so you know what I'm going to talk about. But there is a survey from Ohio State where they did a survey that what is the 10 greatest invention that we have since last 1,000 years. There are a lot of them, out there that is in the top 10 list. And number one in that list came out to be printing press. Why so? Before the printing press, this text information, now we take for granted. Text information is now everywhere. We can easily access it. But before printing press, text information was expensive. But in order to have a book, you need to hire somebody to transcribe by hand. Then that's how we can get a book. But not everybody can have a book. But nowadays, after printing press, we have a way of generating this text information in mass, and now we can go to the bookstore, buy a book, and everybody has an equal access to this kind of text information. Same knowledge to video content. In old days, those mass media like ABC, NBC, Fox, those are the ones who has the power to generate this kind of video content, because in order to create a video content, you need a lot of resources. This is an example of professional studio. You need to have professional cameramen, audio engineers, light engineers, and all those kind of stuff. Not even that. Behind the scene, there's another large group of engineers working behind it to add to the live editing of those video content and streaming to your audience. Nowadays, we don't need this. This is about 2 or 3 years old. The photo of my desk right now. You see that we have 2 monitors. This is a screen that monitors what is being streamed out. You have a microphone here, lighting. This is an audio switcher so that I can mix up my voice with music, someone else's call, etc. We have 2 video switchers here so that I can stream my the face with my computer screen, whatever. You see this before. We need to have a large number of people in order for it to be generate professional videos. Now can just do this by yourself. Right? It's a complete change of landscape. It used to be those one who can generate those kind of information who has the power. In terms of text, those people who has the money. Now, in terms of video, those are one who can generate those kind of video content, like in a big mass media. They are the one who has the power before. Same thing for the remote sensing data. In old days, you need to have either helicopters and an airplane and satellite, to collect this kind of data set. And not only this, probably Dr. Habib already knows very well about this. This is one of the airborne sensor packages going to the airplane. You know how much it cost? Millions of dollars, right? So there is no way, as a personal, one of you can spend, tons of money to buy airplane and sensor packages. And not only that, you need to hire a pilot. You need to pay, the maintenance cost for those all those in airplane. There is huge cost, to it. So there's a reason why there is an aerial, surveying firm, out there where they just provide this kind of services. They make a lot of money. But look at, how it is working now. Drone technology is completely changing this landscape. Now you don't need to be a millionaire to purchase all this kind of hardware. But this is a Photoshop, the shoot of my research group. We actually went to the Logansport to collect the LiDAR data over the Lower Dam over there because they are demolishing it. But see, even though there are multiple persons here, Joshua, he is the one who is operating this drone by himself. So this remote sensing data collection is getting easier and easier. But this is an example that I showed you earlier. I just sent the data set over the link. You just saw this in a very high resolution images. Just do the QR code over there. So the part that I talked about here is this seeing the unseen part. Now, you guys have access to this kind of technology where you can see things where you could not see before. This drone technology is one good example. I can be there. I can have all these corners, fly the drone, get very high resolution images being generated. Just look at that, generate images on your the screen. But I think one part that I like to push this one step further is, whenever I'm seeing what I've never seen, this is great, but even better when I can share what I have seen with others. This is another example that I prepared. This is, the Hubble's telescope, this over here. So there is an straight, telescope out there. You can keep zooming in and zooming in, zooming in again. And I believe the area that we are targeting here is somewhere over here. And later you're gonna see some images that is, very famous. I really don't know what is the name, but this is where, stars are being generated so far away. Okay? And we can see this kind of stuff because of, hardware development, like in Hubble's telescope. This is images taken by Hubble's telescope, but now you guys know that there is a better telescopes out there, James Webb, and they actually took the same location, but comparing to this one here, you're gonna only see this, dust over there. You don't see those, stars in the back. Now with this, better telescope, there's, so many stars out there, right? And this is an example of an agriculture, of course, I'm just emulating this, you're far away, you don't see that much detail. As you're getting close and close, that's what the drone does. You start to see that, hey, there's a lot of detail that we have never seen before. Okay, so seeing the unseen part, due to the hardware development, now we can see things where we could not see before. The more important part is, how can we share this great, out of your work with others? That's the part that has not been addressed yet. And, going back to this analogy of, text information, used to be a lot of, money to make this information. With the printing press, now you can do the mass generation. But the next innovation coming in here is that now with the Kindle or all those in the internet, it is so easy to share this text information with others. And pretty much, all text information that is out there has been already digitized. And guess where this, the machine learning AI making the most progress right now? Large language models. The reason why is because those text information is accessible by machine, right? Same back, going back to this, video content. In old days, I'm not sure, some of your younger generation, you don't know how to watch movies, but probably some of you already know. In old days, you used to have something called, Netflix, or, Netflix used to be not a streaming services, but you just rent a DVD, right? Go to the Netflix website, just click, they're gonna mail you a DVD to your home, then you just get it, put into your the DVD player. That's how you consume your the video content. Now we don't do that anymore. Everything is pretty much all this video content is available on YouTube. And this is a surprisingly or a very scary number to look at. If you look at the market share of media players and streaming platforms, 98% of them is occupied too. And this is the guy who has the most number of subscribers in YouTube, and he has 260 million subscribers. And of course, I think he has a whole crew of people behind him to generate this kind of video content. But compare this guy against those big guy, ABC, NBC. He's a small player, but I think he is a lot more impactful than those other big mass media group. Everything is completely changing because now you can generate the information by yourself, but thanks to this YouTube, now you have a way to distribute this grade your work with others very, very easily. And I just mentioned, I always excited to watch my work, but when it comes to sharing this work with others, that's the part where most of guys, you guys are getting frustrated, and that's where we come in. We start to develop this platform called data science. Going back to this analogy here, all this hardware advancement makes you collect a lot of data. But what is missing here is that now you collect the data, generate some some work, then how can you share this data with others? And through this web interface, this is some of the examples that you saw earlier. This is some 3D point cloud example that I showed earlier. Now everything is going to be accessible. And what I want to do now is that want to do a live demonstration of this data science platform and see how great this is. Right? And hope that every time I do this live demonstration, something goes wrong. But hopefully today, I hope nothing is going wrong. Coming back here, data science URL is in a ps2.d2s.org, and easy way of memorizing this URL. And you guys are gamer, PlayStation 2, PS2. Of course, it doesn't mean that PlayStation 2 is a Plant Science 2.0 initiative. That's the one who's they're giving me funding to get started. So PlayStation 2 data to science.org. That's the easy way of memorizing this URL. And if you just go there, then let me just sign out. There is a sign up button here. Put your name, email, and password, and create an account. And you need to confirm your email. And one of us will approve your account right away. Then after those two things happens, we come back here. We can just click and log in. Then you're gonna log into this page. I'm not gonna go into every detail of what you can do on this platform, but essentially, once I logged in, you see a lot of numbers over there. These are the number of projects that I have an access to. So looking at this in the top left corner, I have an access to 318 projects, but this is not all the project that is not available from this platform. There are hundreds of other projects that has been created by others, but I don't have an access to as well. But simply these are the examples the project that I can access. And if you know the location, you can just simply zoom into that area, then these numbers will be updating. And the one example that I showed you earlier is that Kiptini Biodiversity Station. This is the data set that I shared with you last time. So once I click this in a project, then you're going to see all the corresponding flight. And I just showed you one continuous 170 gigabyte automosaic images, but it is about 2,000 acres of land. Using drone, we just flew at 150 meters, and it takes a long time to cover. So actually, it took 48 hours to cover this whole area. We had to divide into smaller kind of chunks, and that's the reason why we have so many flight over here. So we have a multispectral LiDAR, collected over this area. We have some smaller pocket with a very high resolution RGB image collected as well. So you see on the left, there's all those in different flight. And all you can do here is, let's say, I'm interested in multispectral. There's a lot of them there. This one here, create orthomosaic, and this is the one that you saw before, right? And then you can just zoom into the area that you are interested in. And what you're going to see is that as you zoom in, the high resolution is going to be rendered. So technology behind this, and we store everything as in a cloud optimized data format. So once you upload your data product, it's going to convert it to cloud optimized. Then this cloud optimized is going to be sent to our dynamic tiler, and this dynamic tiler is rendering these tiles on the fly, but not sending you a whole file, but only region they're looking at. That's the reason why we can render this in a gigantic file in a very, very quick way. And this is a multispectral imagery. So we have a band 1 to all the way to band 7. I'm just showing the combination of the 745, which is near infrared, red and green combination. This is a very popular color composite. But let's say I like to do natural color images, which is 1, 2, 3 example. Then I like to use a min max stretching here, click apply changes. And now this rendering isn't happening on the fly. So if you have a multispectral data set, like you guys are using any remote sensing and GIS software, you can just do it here as well. Okay. And when you have single band images, let me go to the LiDAR example. All here, we further process this to generate the digital terrain model. Zoom out. So any of you guys who play with the LiDAR data set, we can essentially virtually call all the trees so that we can look at the photography as well. Here you see that transparency a little bit, and this is how the terrain looks like. So we can just render single band images with a different color map. So I'm just using the rainbow here. If you click this, you can just apply different color, the map over here. And let's say you are interested in Earth. You can just do all those dynamic rendering over here as well. And whenever you have a point cloud, we choose one of the LiDAR flight that we got. Just do 5. There's a point cloud. You click this, then you can actually see this in a point cloud in 3D. So you can start to zoom in from this to the ground. You can do this in a 3D visualization over there. And one of the since this is a College of Agriculture, I need to show some agriculture example. So I need to show you Cornell Wheat 2022. Example here, we see all those in a different flight. The RGB over here. Right here, and you can just zoom in. You see the wheat field over there. You can calculate the excessive greeniness index. You can choose the other one that are called stretching. You can see all those individual rows, and I'm going to show you how to do the plot boundaries later, but you can unload a vector layer on top of it. And if you just click each of these layers, they're going to calculate the general statistics on the fly. So within this in the polygon, what is a mean, max, average, standard deviation of the specific value that we're looking at, calculate on the fly over here, and do that kind of stuff. And the other thing is that, like I demonstrated earlier, let's say we have one orthomosaic images, and it says sum this up, and this looks great. Then I'd like to share this with others. The way that you can do it here is scroll down. There's a button called the share, and by default it is actually restricted, meaning that the only person who has an account and who has been added to this project can access this data set. So if I'm not a part of this the project, that I cannot even see it. But what you can do here is I can just copy, change it into anyone, copy this in a share URL, send this link to your colleague via email. The other colleague is going to click the link, and they're going to be able to see exactly what you see over here. Okay, so this is makes very easy to share data set with others. And we also do support actual data processing when you have a raw data set collected. So if I go to peanut demo here, and we just have one flight created over there, main data. If you go to raw data here, it's uploading everything as a zip file. There is a pink button says in the process. You could click this one. I'm not going to do this because I learned the process so many times, but we are using MetaShape in the backend. Just choose an option, check to proceed and submit job, and this job will send to GPU cluster that is located in AB building, and they're going to do all those automated processing and push those back those data product to this flight. And once you do this, then you're going to see this data product generated using the ortho photos in a point cloud and the PPM. So you can just do actual, the raw data image processing on this, the data science as well, data science as well. So these are some of the very high level kind of explanation of what you can do with this. But one of the key features that we like to highlight in this platform is that not only you can do a lot of this kind of stuff in this web, but we designed this data science system as an open architecture, meaning that anything that you saw here is going to be accessible from any other computing platform if you need. So what we did is that we developed a QGIS plugin. where you can actually log in to the system and stream all those data sets that I just showed you to QGIS. It's a single, single click of button. And let me just show you. If you go to QGIS and go to plugin and manage them for plugin over there, if you search for data to science, you're going to see this in the data to science in the browser over there. Click install. Then I already installed this one over here, data to science browser. Then it will ask you what is the server URL. In this case, PlayStation 2, D2S.org, my email, and my password. Hopefully, I don't expose my password. Oh, can I stop sharing for now? You guys are gonna see it, so please don't take any pictures. At least I'm not sharing to the Zoom.
Yeah.
I'm gonna be really quick. Copy done. You wanna show back?
This is recorded.
I know. The recording only done in June, so I only shared it. So. So I'm gonna change my password. So quick login. And now you see that. Now something happened, but you see those in a project in a flat has been populated. So let me go back to that example that I showed you, 170 gigabyte automobile file. You choose that 15 by devastation over there. I'm gonna choose multispectral whole. Then you see these an automobile images. I click add to selected map. Now, this one loaded in about a second. And I told you, this is 170 gigabyte in size. If you're downloading this, there's no way you can load this in a day, probably. It'll take easily a couple of hours, even though you're on the same local network. So you see how quickly you load it up. But the beauty here is that you are not, it is not sending all the information. They're only sending you the low resolution information that is needed to visualize it. So if I just zoom into this small area, you see that the blue progress by the bottom. They're now streaming only this region at the resolution that is needed. You see that this has been updated. So now you have an easy way of accessing pretty much everything on this data to science using the QGIS platform, very, very easily. And the beauty of this is now anything that you can do in QGIS, now you don't need to have the data set download to your local machine. You can just stream from data to science and do this in ideal data processing over there. But this is one very powerful features of it. And we had a workshop very recently working with a group called the Field Image R. And if you guys in agriculture, in the phenotyping, Field Image R is a very popular R packages to do the phenotyping analysis. And that they already have all those Field Image R capabilities implemented in QGIS. So it's just matter. You have a QGIS Field Image R installed. You stream this data set from data to science. You can do all those analysis that Field Image R provide can be done without you to install any single software package. Okay. One other thing that you can do is, going back to here, we also developed a Python module. And I believe that a lot of you guys are a Python programmer, and most of those state of the art. Okay, so all those most of the deep learning libraries are available in Python anyway. So we just I'm a Python programmer, and most of my group is using Python as well. So we develop Python packages to access everything that I showed you inside the Python as well. So all you need to do inside the Python is a pip install D2S Pi. I like to call it D2S Pi, but it's kind of easier to find. So once you just do this, and you can just do pretty much everything that I showed you, filtering through the project, filtering flight, get specific data product, load this in a data product inside the Python module, then you can do whatever you want. And if you just go to this guide images here, there are a ton of examples you just already generated. For example, how to create a project, how to create a flight, and how to even unload your data set. So right now I'm working with, the Ben Quinn's in the group. They collected tons of, yearly data set for last, 3-4 years. And, imagine that you're gonna manually clicking through all those in a flight in a manual upload, all this kind of stuff. It's gonna take forever. And but we are using this in the Python code to, automate this onboard process. So you just simply write a script, just, run this code. They're gonna just, go grab all the required information, create a project programmatically, create a flight, upload the data product, upload the raw data, everything. And you can just, automate this process. And this is one example. Another example here is that adding multiple data product to a flight. We can visualize data product using a leaf map and clipping rest of data product and etc. So there's tons of examples out there. But let me see. Visualize product in your leaf map. So let me just show you that this is possible. So any Jupyter Notebook environment is going to run this in a code. But one good thing about this in Python is that the Google Colab, Google provide, free Jupyter Notebook environment for you guys. And you can run this code in Google Colab as well. So what I'm going to do is I'm going to click this opening Google Colab. Then I'm going to say, hey, I need to install these two packages that I need to run it. I'm going to click run anyway. And this is a virtual machine Google provides that installing all those required packages. Hopefully they're going to do soon. See, they're installing all those packages. A second, then this is going to finish running. Installing a lot of packages. Okay, and now I'm going to load the module. And I'm logging into the PS2 instance using my email. I'm gonna log this, and it's gonna ask me a password. I already copied it. Hopefully, oh, do I have to share again? Let me just quickly.
Close your eyes.
Coming back. I just copied it. Paste it in a login. Then I'm logged in here. I'm getting all the projects automatically. Yeah, I just printed the first one, getting the central goal in a project, putting in the pandas data frame. Then I'm just simply plotting on a map. So what I did here is that you're going to see the same interface that you saw that from the web. I just recreated that interface using how many lines of code. And basically, I'm just demonstrating everything that you can do in this data science. Now you can access this programmatically. And because this is the real power of this in the data science platform that I mentioned earlier. In order for you to do the big data driven AI model, you need to have your data set machine accessible. This is truly makes your data set machine accessible right now. And you don't need to worry about, hey, where's my data? As long as you're connected, you can programmatically access all your data. You can share this data with others. You can develop your own pipeline. You can send this code to others, and the others should be able to run exact same code that you're running in their own computing environment. Okay? And this is one example of, many of very small several examples that I'm demonstrating right now. Another one that I want to demonstrate is an event. If you're ready, can you share your screen right now? I'm not going to share my screen, but I think we need to switch our computer to PC. And there is another group from digital forestry called iForester group. They are developing a smartphone-based app where they can actually do the measurement of the trees. So you can measure the DBH, do the species identification, all those kind of stuff. Now, this is another very interesting data set, but because of the open nature of this data to science, that app can be integrated into our data to science platform. And Ben is going to demonstrate this is not a the production site yet because we're in the development right now. For example, let me just go through it. So you see that, imagine that all those images coming from, Forest app that is imagining the field that shows you that where those images are being collected. And on the top right, you can just, filter by, you cannot see it, but what is it? DBH?
DBH.
So you can filter by DBH, a certain range. And you can also filter by height, and you can filter by species. And as you just change those filter value, those information is updated on the map live. And whenever you just see those cards, you're gonna see that what is the, you see it from here. What is the DBH measurement? What is a species? All those kind of information displayed over there when you click this card, because this and iForest that generate depth images. We can go back and forth between the actual IV camera images and depth map images as well. But imagine that this information can be coupled with the UAV data set. In addition to that one, I know I'm running kind of out of time, so thank you in advance. But let me just share my screen. Back to my laptop. And we also have something called Spatial Temporal Archive Catalog. This is pretty much a open standard and make your data set discoverable. So what we are working on right now is that we're trying to make some kind of publication mechanism where you have your project created on data science. You can publish your project to the public through these Stack services. So you see that there are different collections out there. We don't have any D2S project posted over here, but we are working on it right now. We are also working with Purdue library or per group, so we can attach DOI number to your publication as well, so that others can cite your publication. And some of the other collection that is available here, we have a 3DEP, which is an airborne LiDAR data set collected by USGS program. You have an access to 3DEP program nationwide programmatically. You also see the native imagery over here. You can also access native imagery in this set as well. So the way how it works is a quick search. Then I'm gonna search by an extent. Let's say when you go to Purdue campus, let me just zoom in. Say, I like to know what data set is available in this area and like to search for 3DEP and native imagery and bottom click submit. And then we give you all those available information once you zoom in. That image is going to be being landed automatically because everything is cloud optimized. You can grab 3DEP here. This is in a 2013 Tippecanoe County LiDAR. You also have Indiana statewide 2017 LiDAR data set here. By clicking it, it shows an extent. Now you can copy this in a URL and go to COPC viewer, cloud optimized point cloud viewer coming back. Then you simply paste that link that you just grab from there and click enter. And now you are seeing the 3DEP LiDAR data over your campus. I'm not downloading anything, but you can discover the data set you need. Everything is cloud optimized. Now you can stream this information to whatever the content plan you have. Now I'm looking at this in 3 different layers. You have IoT, device like an iForester. It can be any sensors out there can collect some kind of information. They can stream their measurement to this data science. You can manage your own drone data set to be managed big data set. You can link this data set with other external, the open, geospatial data set like in the 3DEP, NAPE. Not only that, Sentinel, Landsat, both of them has Stack services out there. Now you have a freedom to mix up all those resources very, very easy way. In old days, what you need to do here is that, hey, this is my study area. I need to download Sentinel, Landsat, NAPE images in a point cloud. You're gonna spend hours, even weeks and months to do this. Now you don't need to do it anymore. Because now you can write a program to discover your data set. Now you only stream the information that you need to do what you want to do. So I never thought about this, but there is a very, famous commercial. What is that? Only pay what you need, or is that only download what you need? Don't download everything. This will make your life a lot easier. So, did I miss anything? I think I covered everything. I know I'm only forming the last one question. I'll be happy, more than happy to answer any questions.
We have time for a few questions.
Definitely.
Thanks so much for your presentation. I have like one quick question about the platform which you were showing. So is it more kind of like things code which is we use for getting the IoT data up to the cloud and trying to visualize rather than like it's a data repository where we can get the
Pretty much the same, but a lot of things, what is happening out there is everybody's developing their own database to put your database in. But a lot of times this database, you only have an access to, how others can discover the data set you upload or stream to your own database. What we like to do here is that we like to develop open ecosystem where everybody can push the data set into this platform, but it's going to be very easy to discover and stream to whatever the computer platform that you need.
So once we upload the data, would it be accessible on your end also? Like you can also see how this like data security is like.
I showed an example here, this data science, let me show the statistics. So right now, this website has 378 users right now, has 456 projects. You see that how many projects I have access to? I have about 300, right? So there's about 100, more than 150 projects that, I know where they are, because all the information that I get here is that if I click this map here, this gives you, where all those projects are located, but I cannot access the data. So if you upload the data, it's yours. Even Ben and I cannot access it. Technically, if you want to, we are the server administrator, so we can go behind it, but there is no public way of accessing your data by others once you upload it. The only way this is going to be available to others is unless you make it available to anyone, send the link to others, or you just publish to a stack later we're going to develop in the future.
So Dr. John explained to me earlier about this. Basically, in a sense, we all know YouTubers. You want to develop a YouTube version of this geospatial data. Everyone can freely upload and share. And if you don't want to publish it, no one can see it. And I think today what else he demonstrated is that it's not just the YouTube videos, which is, the pretty pictures. But now there's an extended capacity being built is that now you can analyze the videos that have a pipeline built. What's in the video? How many cats, how many dogs, how many people are smiling? That's the capacity that he's building, and without downloading all the millions of YouTube videos, but directly streaming it sort of behind the scene. Now you can analyze all this wonderful information within the videos, or in this case, the images. So and then again, you guys are lucky bunch in the sense that I'm just showing my age. When we were doing GIS in early days, we can digitize our own data, and then later you can download the data. But now you don't even need it to download the data. So that's the power, I think, that what Jinha is telling us. And really, if you we'll have time to maybe for another question or so, but if you really want to learn more about how to use the system, upload the data, or stream, consuming the data, analyze it, go for you guys have workshops, right?
We have a YouTube channel. We have tons of the training workshop recorded.
Yeah. And so use that as in a way to get yourself involved. From my point of view, this opened all of it.
So I'd like to finish my presentation with one phrase. Remember, seeing the unseen. would like to go from the seeing the unseen to sharing the unseen. Like Songlin mentioned, I like to push, one even further, going from sharing the unseen, analyzing the unseen. Now you have a way to do it in this platform. So, we are somewhere, seeing the unseen is, done by all these hardware developers. We already, I think I'm pretty confident to say that, now you can share your unseen with others, very, very easily. What I like to pursue, my group, the next step is, can we analyze the unseen so that we can get insight from those unseen data in the future? And working with all those great scientists here, Purdue.
So question, you mentioned about the surface data for the phenotyping research. Anything about the undergrounds, let's say, for example, thermal phenotyping will be impacted by the tile lines that we have underground. So is there any data that will be?
I don't have any thermal data set here, but thermal data is under the geospatial data. So you can know these thermal layers and you can visualize them as much as you want. Another layer that I can talk about is sun. We're working with the Egg Alumni Phenotyping Facility. This is another big pipeline that generates huge volume of phenotyping data set that we are working together to integrate this indoor phenotyping data set into this data set as well. So imagine that now we have a field data set coming in, greenhouse data set coming in here. Field measurement is coming from IoT device like an iForester, that is you're just leading this in IoT for ag group. All those stream of data set can be integrated into this platform because of the the open nature of this architecture.
One question, what concern regarding the platforms is the long-term sustainability? What is your vision about that? Funding, support?
Great question. So I'm writing a lot of proposals. So I'm very grateful to get seed money from Karen's office at the beginning of this project. We got a couple of small seed grant from USDA. Right now, I'm working on $1 million proposal that is going to submit to USDA probably next month. And we will keep writing this funding proposal to those federal agencies. Another kind of social income for us to keep doing this is that I've been going to a lot of conferences talk about this platform. There's more and more people very interested about it, and those commercial breeding companies, seed companies, they are very interested in adopting this to their the breeding program. So I am in conversation with one of the actual seed companies to develop a agreement so that they're going to adopt this to their breeding program. And how can we support that? I think there can be another, income source to keep doing this kind of stuff. But I mean, I'm not worried about funding at this moment. Once I build this in a community, I think the money will come. So what I recommend, to all you guys right now, for those who don't have an account, go create an account, start to play with it, download your data, and you'll love it.